Alright, if you have not seen my video on Radiation 101 or the Moon Landing 101, the Radiation I Told You So video, please watch those first because that'll save a bunch of time having to put inserts in this video showing GSI lectures and Princeton lectures and things like that that talk about why it is that the magnetosphere keeps us safe from deep space cosmic radiation, as well as just all of the solar energetic particles and mass and light from the sun as well. So this video right here I wanted to talk about because, could we terraform Mars? Now I've also made videos off, like their South Pole, North Pole swap, and that's a fun one if you want to check it out, I suggest it. However, this one I really wanted to talk about, mostly because they're once again admitting that to leave Earth's magnetosphere, you have to have one on your craft. So like I've been saying, now NASA's saying, everybody's saying, because GSI came out and said you have to have active shielding in order to leave Earth's active shielding. Passive shielding only works within Earth's active shielding, so I mean we could use polymers and transitional metals and all these type of things within the active shielding, but if you just go to NASA Goddard on YouTube, it's their personal, it's NASA's.gov's YouTube account, and you look at their heliophysics sections, you will see that the last 6 months, 8 months of videos have been nothing but talking about we need a magnetosphere in our crafts in order to leave the magnetosphere. But as soon as we figure that out, we're good to go. That's why Russia right now is working on isotopes that will create enough electricity to potentially make an electromagnetic field, while we're still using liquid propellants to launch them and control the crafts, hydrazine to move around, all that type of stuff that's the normal system, but we're going to put radioactive materials on it now in hopes that we can create enough energy from those to create electromagnetic fields. So if we can do that, maybe we can go up to 1,000 miles up, where the Apollo 13 astronauts got sick and ended up dying from the cancer that GSI showed you would get if you go up there. And eventually then we will be able to leave Earth's magnetic fields and go to these places and see what we can do. This video talks about a very interesting machine. I really want to point out what they call it and the nonsense it is. So this is a longer video they made. However, this is worth it. Stick it out with me.
Thanks to LEGO presenting LEGO City for their support of PBS Digital
Always
Studios.
a corporate sponsor.
Humanity's future is glorious. As we master space travel, we'll hop from one cold, dead world to the next, terraforming as we go. Life will blossom in our path, and eventually the galaxy will shimmer with beautiful Earth-like orbs.
Right.
I mean, maybe. Sounds a little science fiction-y, but it wouldn't sound so far-fetched if we proved we could do it at least once.
How about you guys prove you can get above 230 miles up and actually habit any area above that? Ever. Start there. How about, if you don't want to start there, you start with what is Earth's magnetosphere? Because it's not an iron core, because Uranus and Neptune have shown that it's not an iron core. So what makes individual gravitational states? Neil Tyson just says, why ask why? Everyone else is stating, Venus is showing climate change. Why isn't it having a magnetosphere? Nobody cares. It's not worth the money investing in it. The toys might get broken. Who cares? That's SciShow's stance. This is where everybody's at. Why not show me you know anything around you before you go and claim you're going to take everything else?
If we successfully terraformed Mars.
Right. So this is PBS Space Time.
We already have the technology to bring humans
Dreamers.
to Mars and to set up small settlements, or at least we could do within a generation. But those settlements will need to be cocooned, shielded against the deadly cold, the intense radiation, and the fatal lack of atmospheric pressure.
The deadly radiation. Well, first off, I want to point that out. Here on Earth, we have like 0.1, 0.01 in some places millisieverts of radiation per year that our bodies take in. All right. International Space Station gets like 200,000 millisieverts per year. That's about it. That's why, with you don't want too many X-rays. That'll boost it up to space station levels if you get, camo treatment and shit like that. So if you're up on the International Space Station, you want to come back, you're going to want to get some treatment. There's a good potential risk of cancer, but it's very unlikely, especially if you adhere to all the treatment. And anything above that, No, not even possible. See, once you start getting into the plasmic states, like the plasmasphere, let alone just in the upper band of the thermosphere or anywhere in the exosphere above it, before you even get into the plasmasphere, let alone way outside of that into the magnetosheath where there's tons of turbulent plasma that's even heavier, and outside of that is 99% more of what all of that was, and outside the bow shocks, 25,000 miles out. So if you were to manage to get any 1,000 miles up, within that first midsection, upper section of the thermosphere, yeah, you're going to get cancer and die. GSI, Marco Durante, he's lead physicist for all particle research and engineering in Europe, and shows NASA what they need to know when it comes to this information. He showed what happens to the human cell, and well, it was a perfect example and proving exactly what happened to the Apollo, 2 out of 3 of the Apollo 13 members when they went about 1,000 miles up, and that's why everything else in the final Apollo mission was 230 miles up, where Russia is now when we met them then. They've owned it since we met them, they own it now. We're all trying to get to the 1,000-mile point. We're starting to make robots because we know that the magnetosphere is something we can't figure out. So why don't you start there? Figure out how to deal with the 200,000 millisieverts to 700,000 millisieverts that you'll experience. So then you'll know how to actually create this shielding that you need, because there's no active shielding like GSI says we need to have to make this a functional system, because passive shielding can only be a solution on the planet with inactive shielding. So if there's no active shielding on that planet, this passive shielding is not a solution. It needs to have a magnetosphere, which they'll touch on later.
Surely, if we want to thrive on Mars, to turn it into our second home, these settlers, or their descendants, will need to be able to open the airlocks, shed their spacesuits, and step out onto a survivable surface. We'll need to terraform Mars as our first step to terraforming the galaxy.
I just want to point out that being that the environment there they're shielding themselves from is 700 millisieverts per year in dose, obviously the ground has gotten that as well. As they're talking, it's all carbon and irons. That's one of the best conductors for, to become a heavy element. They get ionized very well. So I'll assume that it isn't unfathomable to believe that the entirety of the Earth or Mars' surface is like carbon-14. It's not moving at a phenomenal rate, but it's incredibly heavy and incredibly radiant, which, well, you don't want to stand next to that. That's like standing next to the elephant's foot at Chernobyl. So obviously, we can't stand on it. So the shelters they're saying we need to make are nonsense. And obviously, we need to shield from what's coming down on us, as well as what the radiant environment that has been radiated long before we got there is putting out on us. Which I guess the last thing they talk about in this stupid little video is we need to create magic bubbles like, the fucking fairy from The Wizard of Oz and float around in that. Because this is the last option that we have, because we can't figure out magnetospheres.
Terraforming Mars has long been a science fiction dream. From Kim Stanley Robinson's Mars trilogy, to Total Recall, to the Red Faction game series, to Elon Musk's Twitter feed.
So, first off, their entire proposal in this video is step by step what the plot for Total Recall was. And everything that the machines and all of that were doing, that's exactly what they're going to walk us through. So that's how dumb that is. Followed by, did they just say that everything that the Starhopper and all of Elon Musk and the presentation that SpaceX and NASA have been giving us is science fiction? Because that's what that sounded like to me. They just lumped it in with all the rest of the science fiction artists. So what's with all of this moon landing and Mars landing propaganda?
But what would it really take? How science fiction-y is the whole concept of terraforming? In the end, it's a question of atmosphere. Mars' current atmospheric pressure is 0.6% that of Earth, and that means circulatory shutdown within a minute for an unprotected human. But it also means almost no greenhouse effect. Light from the sun, which is already fainter due to Mars' distance, is radiated directly back out into space.
Okay, I want to touch on a couple of things. First off, distance doesn't matter. Our magnetosphere shows that. Also, the sun has a magnetosphere, and the properties within it also would, like our bands, show to be potentially more turbulent the more distance you get from the sun. and so it would be in a more radiant environment, technically, according to the bands of our magnetosphere and the properties in which we're saying it and the sun share in similarities. So, as you look at all heliophysics understandings and you realize the similarities with all of those, you would have to accept the fact that it's not just that there is a reflection, it is that the electromagnetic fields hold and pull the light within and move it just in ways that allow or don't allow specific things to molecular structures potentially to form.
On Earth, that same light first bounces around in our big atmosphere, heating it up.
But what it takes to get to our atmosphere is something amazing, and we're now acknowledging that gamma ray and X-ray interference work with alpha and beta particle interference in all of the various bands, all the electromagnetic reconnection points and the anomalies that happen from the neutral point to the magnetosheath that make it possible for all of these things to come through the north and south poles to allow the radiant environment to cause the warming and allow the atmospheric density to occur and exist as the Earth has. But Mars needs that.
An average of negative 60 Celsius, water freezes on Mars, but even if the planet were warmer, liquid water would still be impossible in that thin atmosphere. It sublimates directly from ice to gas.
And then the solar energetic particles, the consistent light, the consistent heat, and also any cosmic rays, as well as the fact that Jupiter at times is incredibly close to it and will blow its surface systems apart. There is nothing that will allow it to maintain its structural capabilities as long as there's no magnetosphere.
Of course, Earth's atmosphere protects us from harmful cosmic rays and the most dangerous ultraviolet radiation from the sun.
The atmosphere is not what protects us. The atmosphere is the last step of absorption after all the protective bands of the magnetosphere have either moved it, shielded it, or absorbed it to allow it to become a less dense state, such as within the thermosphere, it needs to be shielded with passive shielding. However, in the exosphere, passive shielding doesn't really work, and we're having to figure out how to make small electromagnetic fields to assist the weakening electromagnetic fields in the upper areas there. However, if you're in the mesosphere, you'll find that where you'll experience the most of the last of the cosmic rays, you'll experience, the first bit of true ionization hitting molecular structures, and so you'll find very strange anomalies of rises and decreases of temperatures and stuff because of the ionization occurring there. But below that, our atmosphere keeps us nice and safe because the magnetospheric bands of the ionosphere from the mesosphere on up keep us safe. It's not the atmospheric properties. The ionosphere is killing half of the atmosphere. It's not the atmosphere that's doing it, it is the layers of and all the bands of the ionosphere and how they coexist with the upper layers of the atmosphere to consolidate and create the mesosphere into what it is. Potentially working with the lower levels unless we screw them up like we're doing with climate change, and then obviously they don't have the best coexistence and we end up losing polarity or we end up losing structural stability or any of these things happen and we become Venus or Mars. Potentially Venus, because Mars has never been, and I'm going to touch on that in a minute.
All of that bad stuff has a direct path to the Martian surface.
Bad stuff.
So, the most important step in terraforming Mars is to give it an atmosphere, ideally as close to Earth's as possible. In the imaginations of sci-fi writers, all we need to do is unlock the planet's latent potential.
Make a magnetosphere.
Mars was once a warmer, watery planet with a much thicker atmosphere. That's conclusive. Our rovers and orbiters have found incontrovertible evidence of an ancient watery surface. The hope then is that this water and the atmosphere that once supported it is now all locked in the planet's crust and ice caps.
Now, before we go any further, I just have to point out one simple fact. Mars never was. Atmospheric density never existed. It has always been a dead planet. We can see every celestial body, whether it's a small asteroid or a larger planet like it, collecting hydrogen, various elements, creating ice. Now, they talk about this all the time, that there's a huge difference between liquid water and frozen waters. And so out there, yes, this is ionized water. It's not the same as the water we find on Earth, so it cannot be thought of and used the same as the water on Earth. So there was never, and it's because we don't understand magnetospheres, there was never the ability to say it's because of the iron core stopped or slowed. They'll touch on this. That's not what actually creates the magnetosphere. Once again, the properties of Neptune, Uranus show with their axis being off, everything not coinciding with the properties of Earth's magnetosphere. It's not the same thing that creates it. I'm still convinced that the magnetospheres existed and these celestial bodies fell into it. That explains why, in old times there's stories of Venus flying through the solar system and falling into its orbital pattern. This makes sense for various things. I still think that there's a potential and science we haven't looked into. That's another video for another time though. So Mars never was. Final thing I wanted to say about the dried up riverbeds, they are electro fields surrounding them. There's no magnetosphere. All of these ions are constantly within, the plasmic states are within the matter. So if, say, Phobos, or any of these celestial bodies were to come close enough to them, just as we have sprites that go up like lightning goes down, these discharges happen because of polarities that cross or sometimes are just equal, and they allow currents to and from, and that's not riverbed, that's scarring. It's electromagnetic fields creating scarring. So it's never been a planet like Earth's. It's maybe potentially one day capable of maybe being pushed into or around to a point where it can find magnetic fields. Maybe there's, at the end of the video we talk about some interesting machines we want to create to make magnetic fields that we still can't create for our own. Maybe for the planet, an umbrella as they call it, you'll see. It's an interesting realization I had to go through when I realized that was just scarring on the face of Mars.
We just need to release it. Surely we can just nuke the poles, melt enough carbon dioxide and water vapor to kickstart a feedback cycle of greenhouse warming, and that'll release more gases, and voila, Earth 2.0.
Okay, no. First off, Ganymede is Earth 2.0. And I'm tired of discussing it with all the fucking nerds that are just like, nuh-uh, because you don't understand why it's not a star. It's not a failed star, it's a perfect planet. You guys can say whatever you'd like. It's a very clear model for anyone who isn't a zealot to science from the past and is watching the evolution of science now. So I am noticing that it's the third rock from that failed sun. Okay, sure, it's within electromagnetic fields that give it electromagnetic fields. So it has all the properties that Earth has. It's the size of Mars. Everything we need is there. It's not much further away than Mars. If we can get to Mars, we can get to it. If we can figure out radiation shielding, we can figure out radiation shielding. Time is not a, when we're exploring time no longer matters. So people who want to leave Earth, those who are willing like myself to just leave for science, see what happens. Well, there's enough of us, we don't want to come back. Time doesn't matter for us, so it's nonsensical to use that as the argument that, time or, well, the dangers of radiation. Well, then we can't make the stuff to actually get into deep space, and that's why the technology doesn't exist, and they have to come up with these fairy tales. Or you can't admit that you're not willing to allow it to ever happen because, well, the science and technology doesn't exist, and we can't.
Not so fast. There's a real risk that Mars actually lost its atmosphere to space rather than absorbed it into the surface.
Did they just say that, like I've been trying to tell everybody, that the Earth is losing all of the water, thus why the seas aren't rising? Everything is leaving through our onyx state. Every time that we see an aurora borealis, we're like, oh, that's so pretty. Wow, that's amazing. There goes a big old thunderstorm, just gone forever. What also falls up, falls down. Sprites, lightning. It's the same fucking concept. Positive, negative, and they swap. Ever watch the go to NOAA and watch the phi's you'll watch the electrons just flip back and forth all the time. If you watch their charts, you'll find every day we lose so much, almost more than we get in, and this isn't an even balance. We're losing all the properties of Earth that make Earth what it is. So they're again starting to admit that maybe this happens, and that's why the seas aren't rising.
The issue is that the planet is relatively puny.
Oh, and on the seas aren't rising thing, some like fucking sandbars in the Pacific or some shit, like in the Jamaican island area, stuff like that, like the Atoll Islands, all these things, those sandbars don't count as the seas rising. Sand displacing in sand that's surrounded by water is not it rising. That's displacement. Now, if you tell me that 4 inches of water are surrounding the Manhattan coastline and raised up, you know, that I'd be like, oh, and can that be verified throughout other ocean, shorelines? Then shit, it seems that you have a logical study and you have shown that the seas are rising. And I mean, so far the only thing we've got is sandbanks movement. And so come on, like, here we go, there's where it's all going. And obviously our cars, our trucks are cutting down the fucking trees. Timber immunity, right? Fuck you guys. No. This is what we're turning it into with all of that nationalist bullshit.
At 11% the mass of Earth, it has a weaker gravitational field that grips less tightly to an atmosphere. And that small size means that the Martian core cooled down more quickly than Earth's core, solidifying long ago and shutting down its global magnetic field.
Well, that doesn't make any sense because there's other celestial bodies out there, say the moons of Jupiter, that happen to have magnetic fields that are greater than it, and the celestial bodies are smaller or not the same size.
Earth's magnetic field protects us from the solar wind, as we saw in a recent episode.
As we saw in a recent episode, which, by the way, if you haven't seen the episode I did on that with him, then you really need to check it out because it's very interesting. They always show these graphics of everything going around, and so obviously, once again, the Earth is a ball underneath water, and the water is going all around it, and there's an invisible field keeping all the water off of us, and the only thing that the Earth gets, that these inner Van Allen belts get, like far within, there's the plasma sheath, the Van Allen belts are actually within here, because these are not the Van Allen belts. My previous lecture on radiation talks all about it. So, these things right here, this is the bow shock. Yeah, it doesn't allow any of them in. Maybe 1%. And maybe 1% that makes it down to this lower region right here. So that's 1% of the 1%. So we get some atomized dew from the river while we're underneath it. There's your metaphor for the magnetosphere and what Mars is just dunked right on in. And so we aren't allowed to touch the water because, well, that's like touching the elephant's foot. So how do we go through the water to Mars that's in the water if we don't have a craft like the Earth has here that makes these things? So like NASA and everyone has said, if you want to go to the moon, if you want to go to Mars, if you want to leave this, you have to create this.
The unprotected and loosely bound Martian atmosphere may have been slowly shaved away by that window for billions of years. And
or
in
instantly.
fact, that is exactly what happened. The ablation of what is left of the Martian atmosphere has now been directly observed by NASA's MAVEN spacecraft.
I think that this is the Griffith telescope. I think that there are several others that work with it. I don't think that there's anything outside of the magnetosphere, and I think science has done a wonderful job of explaining why my thought process is logical.
As we've also discussed before. And the lack of atmospheric material in the crust has been confirmed pretty conclusively by observations of the Martian surface. In a nice Nature Astronomy article last year, planetary scientists Bruce Joukowsky and Christopher Edwards calculate the plausibility of using the remaining surface carbon dioxide to replenish the Martian atmosphere, based on observations of NASA's Mars Reconnaissance Orbiter and Mars Odyssey spacecraft. They focus on CO2 because it's the only plausible greenhouse molecule in any significant abundance on Mars. They assess whether release of the accessible CO2 reserves could get Mars anywhere near Earth's atmospheric pressure. And unfortunately, they conclude that no near-future technology could hope to kickstart the recovery of any
science fiction.
atmosphere. But you know what? Let's go ahead and run the numbers real quick, because maybe something is still possible. After all, these researchers only ruled out near-future technology. What about medium future, far future? So there are three broad sources for CO2 on Mars. First, there's the South Polar Ice Cap, which consists of water ice several kilometers deep into
Great to view on a telescope. I suggest if you have anything from an 8, 10, 12, 14 inch, Dobsonian or something like that, Newtonian, check it out. It's a lifetime experience.
Double the current amount of CO2 in the atmosphere, which is a factor of around 100 times too low to make a difference. And by the way, that CO2 couldn't be released with nukes alone, it's too deep.
So, again, they just stated very clearly, Elon Musk is science fiction. This is nonsense. There's no moon landing, there's no Mars landing. This is propaganda.
Sorry, Elon. The second accessible source is CO2 absorbed into the surface dust, the regolith, up to 100 meters deep. Unlike, for example, Earth's permafrost,
explosive,
this stuff wouldn't just
radioactive.
melt under global warming, it would shift in its equilibrium over 10,000 years to release a small fraction of its CO2. At any rate, even if we managed to heat the entire regolith across the entire Martian surface, we'd only get 4% of the Earth's atmospheric pressure. The final CO2 source is carbonate minerals in the crust. These carbonates would need to be mined and processed by heating to around 300 Celsius. But complete strip mining of even the largest carbonate surface deposits on Mars probably get you less carbon than melting the polar ice caps. So,
Mars has no magnetosphere. All of the soil that we're trying to pull up is radioactive. There is no using it. If you are a human being, it is like playing with radioactive decay.
Much for near-future accessible carbon. But those carbonate minerals probably exist in much larger quantities deep beneath the surface. And that's really our only hope to find enough CO2, or really any native Martian material, to replenish the atmosphere. Let's do a quick calculation to see what it'd take. First, let's pretend there's an accessible layer of limestone, calcium carbonate, across the entire surface of Mars. There isn't, but hey, we're dreamers.
Total recall?
We need about 10,000 kilograms of material per square meter to duplicate Earth's atmospheric pressure. Seriously, that's how much atmosphere is above your head right now.
Remember the vents they had in that movie that just started shooting it out and the skies just turned blue?
2,500 kilometers per meter cubed.
That's what they're talking about.
44% of its mass in CO2 when heated or exposed to acid. So, to get 10 tons of CO2 for every square meter on the surface of Mars, you'd have to dig down over 10 meters across the entire planet.
Like they were
That's
doing
a few
in Total Recall,
tons
digging
of rock.
into.
I hope you have your diamond pickaxe ready.
Oh, and there's another suggestive fan base drop that obviously the people who watch this show, the people who believe in the moon landing, the people who believe in that Elon Musk is going to take us to Mars. These people are people who play video games. They do software engineering. Their jobs are usually invested in this technology and in these manufacturing positions. So obviously the nationalist pride and the business is what's making everybody decide that this isn't just science fiction fairy tale, and that maybe we'll actually pull some of this nonsense off.
Reality, of course, we need to first locate and then dig down some kilometers before we could access most of the carbonates. Extracting such a quantity from depth is hard enough, but let's think about processing. We can either heat the carbonates to hundreds of degrees Celsius or use acid to dissolve out the CO2. We need to process around 20% of all Martian water via electrolysis to get that acid.
This is assuming that we know what the compounds actually are under the surface.
Byproduct of making that acid. The energy cost in both cases is similar though, several septillion joules, several thousand times the total annual energy consumption of the entire Earth. That's definitely sounding far future.
It's impossible. That's nonsensical.
Quite impossible. Finally, we have a picture of what terraforming Mars might actually look like. Let's say we want to finish this work in a single generation. We need to cover much of the surface of Mars in solar cells made from abundant silicon in the crust, or build 10 or so million gigawatt fusion power plants. There's really no other viable energy source. We need to channel this energy deep into the crust to power vast hordes of robotic miners/processing plants.
This is the Total Recall plot, the movie Arnold Schwarzenegger did in the 80s. This is literally the same plot that movie told us to have, to terraform Mars. This is ridiculous, people.
Nonetheless, our descendants could see a Mars with sufficient air pressure and greenhouse effect to allow liquid water to persist on the surface. Now, Mars actually does have enough water for a few lakes and rivers. The ice cap water would cover the entire surface.
The magnetosphere has to exist for all of that, everything they said, to be possible. Remember all the lecture they just gave about the Earth and how the magnetosphere from Mars doesn't exist and that'll strip it away? It's not going to take hundreds of millions of years. It's just instant. It's why, as soon as we start to send things out, communication is lost. That's why when we send our tissues up, they're damaged immediately. The nucleus is penetrated. The RNA that's produced is unusable. Everything that is touched is cancerous beyond that point. There's a reason for that, and it's because we get the dew point, remember, as I just talked about, as opposed to we don't get the entirety of the volume of that water's lake and river flowing over us, as they show in all of the models. Everything going around us is the river flowing.
To about 30 meters, which is not enough to start a proper water cycle or have oceans, but there may be a lot more water deeper in the crust. We'd better hope so. Our brand new CO2 oxygen atmosphere is not exactly Earth-like. In fact, it's instantly and fatally toxic to humans and animals, and not so great for plant life.
Because it's all radioactive. Everything is carbon and iron and nitrogen based. It's all literally heavy ions, heavy helium, heavy hydrogen, carbon-14, all of these ionized particles that are on the ball that is what we're trying to be on, as well as the radiant environment it is submerged into.
Certain algae can survive in a pure CO2 atmosphere, which is handy.
When they have a magnetosphere protecting them from all of that is the river we were just using as the metaphor.
And we'll need that photosynthesis, because otherwise oxygen will be quickly leached from the atmosphere as it oxidizes the surface.
Just like it's pulled from ours through the ionization of the magnetospheric bands in the ionosphere that pulls things out, as well as pushing stuff in, and how our molecular systems are breaking down in the mesosphere, and why it is that O3 was so important and assisted in keeping the majority of our compounds that we need in, so that it isn't just nitrogen, carbon-based. Bottom line, all of our helium was very important, and we put a lot of it in the atmosphere just for fun, and we lost a lot of it just over time. So
there's our next snapshot of the far future of a terraformed Mars. Brand new oceans, green with photosynthesizing, probably genetically engineered slime, and perhaps eventually a breed of post-humans genetically or even cybernetically adapted to deal with the CO2 atmosphere. I just described
genetically altered to deal with the atmosphere. In other words, that was another subtle way to say everything that I've been constantly spouting, and that is we are trying to figure out two different potentials: electromagnetic shielding, or creating, exactly as GSI's Marco Durante stated we'd have to be, us into the Incredible Hulk, some type of heavy ionic being, something that the molecular structures don't get ripped apart when free radical electrons are introduced and there's too much electricity and our covalent shells lose control of the, it's unstable and we just melt. So, or even worse, they bring stuff in, it penetrates and damages the nucleus of our systems. We create cancerous tumors, even if we survive it. So, obviously, we need to create electroshielding, or we need to create superhuman beings, genetically altered beings, things that can withstand the harsh radiation of 700 millisieverts a year, while still being within all the shelters they're talking about. That was projected data from Mars missions if we were shielded. Now, we're talking a great number more than that, an unpredicted amount that GSI couldn't simulate because there's actually no raw data or even projected data to get an idea of what is actually the raw particle from the sun. That's why we made the Parker probe, and we sent it on its way to touch the plasmasphere, because if we can get a raw particle from up just above the exosphere, just outside of our atmosphere, within the electromagnetic fields that touch the sun's electromagnetic fields, you know, the sun's atmosphere, we can then figure out exactly what the power of that particle is and get a better idea of how, you know, what the water is in that river that Mars is submerged into, and, you know, that little 1% of the 1% we're getting, maybe that 1% of that 1% will give us a better idea as to what the 1% we're playing with is. Then we'll be able to go out and 100% of it to get to that celestial body and hopefully turn it into those beautiful green, you know, lands with amazing blue oceans and what the fuck ever bullshit we want to convince ourselves we're going to do to it. Because we're destroying Earth, why the fuck would we fix that?
The easy path to building an atmosphere on Mars, it may be the only way to do it using only Martian materials. Variations are possible, like introducing super greenhouse gases like CFCs, but that still doesn't give us the needed atmospheric pressure. At any rate,
because there's no magnetosphere, there's no ionosphere compressing everything.
Toxic filler molecule. CO2 sucks. Nitrogen is much better. It works great on Earth.
Yep.
But Mars has very little of this stuff. To really build an Earth-like atmosphere, we have to turn our eyes to the rest of the solar system. One popular idea is just to smack some comets into Mars. Comets contain tons of frozen volatiles. Gas.
I just want to point out that it seems like it's a little bit more evidence for Venus having potential magnetospheric properties, and that's why it's maintaining its nitrogen environment, and like why we might become more like it as opposed to like Mars, and that's simply because these condensing bands of the magnetosphere cause nitrogen, various elements like that to stay. It was to, like, you know, helium, which is lighter, and these things will eventually fall up, and we'll be stuck with nitrogen and carbon and these various elements where there is no ionosphere on Mars consolidating it and keeping it pressed in, so all of these elements, just the entirety of them, just dissipate, and it's only left with whatever galactic particles or any heavy, you know, mass that is ejected from our star that might spatter onto it.
Swarming molecules like CO2, H2O, and the presence of molecular nitrogen in comets was only recently confirmed by the Rosetta mission. But how many comets do we need? Well, assuming comets contain an amount of nitrogen similar to the composition of the pre-solar nebula, then we can guess that around 5% of a comet's mass is nitrogen.
Yes.
That gives the typical medium to large comet 100 billion tons of the stuff. So, to build a quadrillion-ton nitrogen atmosphere, that's like 10,000 comets.
No.
Okay, so we're still in far future La La Land. But it's actually not
Everything so far has been science fiction. Everything so far has been nonsense. All of it because they have yet to acknowledge that it will need a magnetosphere. They said, you know, well, Earth has one. Maybe Mars didn't, and that's why.
Significantly less crazy or more crazy than melting the Martian surface. What would this effort look like? Imagine this. A vast fleet of robotic spacecraft swarming the Kuiper Belt, nudging its plentiful ice balls in just the right way to send them plowing towards Mars.
We ask Russia for fucking rides to the International Space Station they put up there to replace their station that they put up there when they got there and we met them in the Apollo fucking capsule. So seriously, I understand that you guys think that you're gonna just take it all on and the world is yours, but for fuck's sake, have you noticed the world's dying and your fucking stories are old?
Hopefully with exquisite aim, otherwise Earth is in for a pounding also. It would presumably take centuries to put such a fleet in place, and more centuries to deorbit those comets. Once Mars has been suitably bombarded, there's still a lot of work tweaking the new atmosphere. But the good news is that those comets brought with them a lot of water, so we have deep global oceans at this point. Okay, let's fast forward several centuries. Mars has an atmosphere, either released from deep in the crust or brought in from the far outer solar system.
Solar wind is now ripping that crust apart because there's no magnetosphere protecting it from the heavy ions that are bombarding it, ripping apart the molecular structures as we watch as the northern lights strip them all down in our upper mesosphere, and we watch as our molecular structures are tore away and taken off into nothing as our seas don't rise.
The last step is to protect the new atmosphere. We cannot restart Mars's magnetic field. To do so, we have to remelt the entire core.
That's assuming that it's a melted core that is doing it, because, well, I'm sorry, how is it that the core isn't where the middle of the magnetosphere is on Uranus? That's just in itself all you need to go, wait, then if the magnetosphere is outside of the core, then the core isn't creating the magnetosphere. The magnetosphere is not created from an iron core. So of course you can't restart it because it's not what fucking creates it.
But we can try to build an external magnetic shield. The easiest would be to do that in space, an orbiting field generator placed between Mars and the Sun, like a giant space umbrella. The resources and energy needed to build this is insane, but hey, we just built an atmosphere, so why not? Honestly,
wow,
all this is pretty insane, and frankly unlikely. Would we...
One more time. Let's go over that one more
deep
time.
in the crust or brought in from the far outer solar system. The last step is to protect the new atmosphere. We cannot restart Mars's magnetic field. To do so, we have to remelt the entire core. But we can try to build an external magnetic shield. The easiest would be to do that in space, an orbiting field generator placed between Mars and the Sun, like a giant space umbrella. The resources and energy needed to build this is insane, but hey, we just built an atmosphere, so why not? Honestly, all of this is pretty insane, and frankly unlikely. Would we really muster the resources to terraform Mars if we can't do the same to re-terraform Earth?
Ta-da!
There is another option. Why build a sky if we can build a roof? Instead of terraforming, what if we para-terraform? Build what is known as a world house.
This is ridiculous.
We could cover vast tracts of land with an airtight bubble, or more likely, many, many connected bubbles. These would be tall enough to encapsulate entire cities, and importantly, plenty of Earth-like natural wilderness. Oh, and I'm still a proponent of centrifuge cities, maglev rotating habitats to simulate Earth gravity. Also shown rather beautifully in this more practical design by James Telford.
No. I liked, okay, if we're going to talk about all this science fiction bullshit, no. I think that Final Fantasy, the Spirits Within movie, they did a much better bio-web. I thought that their bio-shielding was just spot on compared to this jackass's. So if we're going to go with all the nonsense science fiction stuff, I'm going to go with that, take on, bio-webbing and electromagnetic shielding to keep us safe from electromagnetic properties that we can't figure out, like, spirit ghosts. That was the reason for the shielding in Final Fantasy, because, galactic particles and solar energetic particles are spirit ghosts, which technically, as we're calling synapses, traveling electrons, and that's consciousness, is nothing more than electricity and movement, then, all right, sure, I guess that's a whole bunch of information and potentially sentient knowledge or potentially sentient communicative capabilities. Whenever I'm trying to say that's all right, sure. I'll roll with it. Why not? Take another hit of acid, eat another mushroom, and dive on in, right? That's what we're doing here. Nonsense.
Wanted to cover, say, 10% of the Martian surface with a 300-meter tall world house. It'd require several orders of magnitudes less material than building an entire atmosphere. So, say, a handful of comets and/or the polar ice caps should be enough to fill our world house with air and water. Now, without a real atmosphere, space radiation is going to be a problem for our world house, as is the constant bombardment of micrometeors. People who live in glass houses shouldn't throw stones.
You mean you need a magnetosphere?
Stone-throwing universe.
It's like everyone's saying that these days.
Advanced or just very, very thick materials that would serve. So, there is our final image of humanity's future on Mars. Thousands of city-sized bubbles spread across the still barren landscape. And inside each bubble, an oasis, a lush snow globe replica
For real, like, you gotta be
However
in
we
The
do
Wizard
it,
of Oz now
Mars
to
will
actually
surely
buy
be
this
our
shit.
first step, our proof of concept, if we choose that destiny, if we choose to terraform space-time.
If we want
Thanks
to.
to LEGO presenting LEGO City for their support of
And
PBS
there it
Digital
all
Studios.
is.
Can you believe it's been 50 years since we landed on the moon? It started out with one
Can you
small step
believe
for
that?
man, and now the journey to Mars is right around the
Oh
corner.
man, we're so
Featuring
close, I
sets
can't
inspired
wait.
by real aerospace technology, LEGO City Space
The
aims to
flat
inspire
earthers like
future
Mike
space
Pence and Jim
explorers to
Bridenstine
imagine
say that
what role
we're gonna be there by
Get
2024,
us
you
to
guys.
the red planet.
How cool is
To
that?
discover more,
Just
go
buy
to the
more
link in the
Legos.
description.
Vote Trump.
So we used to
Support
cover
all of
sponsors.
this.
Today I'm going to cover 2 episodes. The episode What Happened Before the Big Bang, in which we look at eternal
I'm done with
inflation,
this.
as well as
There
the
you guys go.
episode on the exciting
I
possibilities
think it makes it pretty
that
clear.
North and South
This is
Pacific
all science fiction.
may be about.
You're not going to Mars. Look at this. Every day they come out with new videos talking about you're not going to Mars. You're not going to Mars because you can't leave our magnetosphere. We don't know what it is. We got ideas. Maybe Russia will figure it out someday. They're messing with isotopes. Maybe they'll end up, not blowing themselves up, and we'll steal their technology. We'll recreate it. Maybe we'll get into space like they're in space and everyone else is in space. But most likely not, because bottom line, I'm going to end this video pointing out that at the same time this was released today, military training was going on with China and Russia together. They just signed a space treaty together. They just signed international trade laws that make it possible for them to. We hit them with tariffs, and they went to each other to work together. And so while we're talking about this science fiction, politics is leading in a pretty nasty direction, and we're not even really allowed in space. We're trying desperately to use Elon Musk and SpaceX here to get to where Russia has kicked us out of, militarized, and now owns, dominates with all the nations that we laughed at thinking would never even be there. India, Pakistan, Jerusalem. Now they're all up there as well. And they're working with Russia and China, and everyone's working together except for us. Because we're 50 years since we landed on the moon, we're on our way to Mars. We don't work with anyone else because we have our science fiction and our stories. We push propaganda like everyone else. But this is our propaganda. We'll see what happens.